It's Frigid Math Friday, and Mr. Jennings is making all sorts of errors with distance learning. I keep on saying I'm learning every day by distance learning, but I keep on forgetting the same things, like am I sharing my screen or am I making a video? Here we are making a video. So when we have a situation like I'm about to describe, where you go up a chairlift that's at a 20-degree angle, and you've risen 450 meters vertically, okay? And then you ski down another slope, which goes down at 25 degrees and is at 90 degrees. So we're going to say that these two slopes are at 90 degrees to one another. You go up on one angle and you come down on another angle at 90 degrees. This corner in here, you need to think about 3 dimensions, okay? 3 dimensions here, all right? This is the vertical height. It is 90 degrees to this distance, and it's 90 degrees to that one. So it's basically like the XY plane with a Z on it, a Z coming out of the page. That's difficult to draw, and as you can tell, my artistic skills are severely lacking. So if we want to know when they come back, like if they want to go from the bottom of this run, which is 25 degrees down this other face of Blue Mountain, it was 90 degrees this direction, north, south, east, west. Like if they rose going north, they came down going west. Okay, so it's 90 degrees to itself. And we want to know how far they need to go to get back to each other here. Okay, to get back to the start of the chairlift, all right? So this is our desired thing to know, is how far do they need to go here, distance. First thing to do, label all your corners. Okay, so we're going to call this corner A, because why not? And we'll use black for this corner, A. And the top of the hill we'll call B. And this point, which is if you drilled straight down from the top of the ski hill and got level with your point A, that would be that point. It's inside the mountain. Okay, so this is like a cutaway diagram. Okay, we'll call that C. And then we have one more point to talk about. We'll call this D. Okay, now if I want to know this length of D, I am going to need some stuff here. The only thing I know is that there's a 90-degree angle in there, but I don't know this angle. I don't know that angle. Notice this is a vertical triangle. This is a horizontal triangle. This triangle is like level with the surface of the earth. This triangle is vertical. This triangle is vertical in another dimension than this one. Okay, so let's draw all of our triangles separately. And that will help us to diagram this more effectively. I'm going to move Hannah and that question over there and make this a little bigger. Okay, that should be good for everybody. So our first triangle is ACB. So triangle ACB looks like this, A, B, C, okay? And it has down here C, and this is here B, and we know that the height of Blue Mountain is 450 meters. We know that this chairlift goes up at a 20-degree angle because I said so. I made that up. All right, now we're going to need, if we want to find this length D, we're definitely going to need this side. Because if we know this side and we know that side, then we could use Pythagorean theorem to solve for D. Cool, eh? So let's label this. We have that called D, so let's call this side B here, okay? And so I'm going to label this side B. All right, now let's find the length of side B. I know that tangent is going to relate opposite and adjacent. So tangent of 20 is equal to 450. For some reason, my brain wrote a 2 there because my brain is dumb. No, it's not. That's negative self-talk, Mr. Jennings. Okay, B is equal to 450 divided by tan 20. If you're saying, whoa, slow down there, Mr. Jennings, then you may not have been watching the videos all the way through, okay? When I multiply by B, B comes to the top over there, and then I isolate by dividing by tan 20, so it goes to the bottom over there, okay? So that's just a very quick, just skipping some steps. Now I can punch that on a calculator, all right? Let's do it. So we're gonna have our calculator. I'm gonna move it out of the way so we can see our, where is there it is, the grabbable part. 450 divided by the tangent of 20. That's the tangent of 20. So I have that this is 1 kilometer and 236.3 meters. So 1236. B is equal to 1236. Okay, cool. Meters. All right. Now, we also want this side so that we can find out, they go up the chairlift, They ski down on a different slope, which is steeper. Okay, so they come down faster because they're coming down at a 25-degree angle here. Because Reed and Fisher are advanced skiers. I expect you can do any run at blue. Probably you can. So let's label this side. We have B, we have D. Let's call this side C and magenta. Okay, and then so now let's draw triangle BCD. Okay, here's triangle BCD. Here is corner D. This is a 25-degree angle. This is still 450 meters, okay? Because that side is shared by both triangles. And then we know that this is a right angle, and we're desiring to find side C. So it's the same. Tan 25 is equal to 450 over C. And so some quick manipulation gives C is equal to 450 over tan 25. I'm expecting C to be significantly shorter than B, maybe even below a kilometer. Okay, let's find out. Move the calculator. 450 divided by the tangent of 25. I've really made friends with this calculator during distance learning. There it is, just below a kilometer, like I guessed. So I make these guesses frequently. I'm sometimes really surprised and sometimes really pleased with my guesses. And there's an example where I'm quite pleased. Okay, so now I know B, I know C. Now let's draw triangle ACD. And then we want to find, after they've gone up the chairlift, they've skied down another slope, how far do they have to cross country ski to get back? It's going to be pretty far. My guess is like a kilometer and a half, if not a little more. Okay, so let's draw triangle ACD, and we're going to use yet another color. We'll use blue, because blue is my favorite color. Okay. It doesn't look in the diagram like that's a right angle. It looks much wider than a right angle, but that's because I'm trying to do some kind of three-dimensional thing where I show you a three-dimensional thing in 2 dimensions. And my art skills are poor. Stop saying that, Mr. Jennings. Say, my art skills are not very good yet, and then maybe my art skills will start improving. I know this is B, and this is 1, 2, 3, 6 meters. I know this is 9, 6, 3 meters. 965 meters. Okay, and now I want to find side D. Okay, D is the hypotenuse. I don't need to find this angle. I don't need to find that angle, but using trigonometry, I could. And then I could use trigonometry to find this. But because I have no known angles here except for this 90-degree angle, it's going to be easier to just use Pythagorean theorem. So D squared is equal to 1, 2, 3, 6 squared plus 965 squared. Don't ask me to do those in my head. I'll be staring up at the ceiling for a while. 1, 2, 3, 6 squared is 1 million. Oh, come on. Come on. Make it easy. Make it easy, magical paper. Magical infinite paper. Okay. 1527, 696 plus 965 squared. 965 squared. So nearly a million. 931225. 931,225. That is equal to D squared. So add these two things together. So this plus, equals? No, didn't work. Okay, clear. Okay, wait. Just push this button. That gives me that number. Okay, and then I add 931,225. Oh, just click. There, fix it. 225. There's the sum of those two squares. And I don't really care to write that down because it doesn't mean anything. What I do want is the square root of that, because what I'm going to do over here, of course, is I take the square root of that and I take the square root of that. I have this on my calculator right now, so rather than write it down, I'm just going to take the square root of it. And there it is, 1.5. Remember I said it's going to be a little more than 1.5 kilometers? Hey, see, I've done a lot of guessing, so that's why my guesses are really good. 1, 5, 6, 8. So, Reed, Fisher, how do you feel about doing cross-country skiing in alpine boots for 1.5 kilometers. Sounds not like fun. That's why there's multiple chairlifts at Blue Mountain. Okay, so therefore, the distance between your final position after your 25-degree downhill run and your starting point at the chairlift is 1.568 kilometers. All right, so these are three-dimensional problems. We will get super confused unless we learn how to take a three-dimensional diagram where we do our absolute best to draw the situation and then separate the triangles and draw them all individually. Label carefully your corners. Take up lots of space on the page. Don't try and do it all small and tiny. Try to expand these ideas so that you get your numbers on there and keep your thinking organized, because that's going to be the biggest source of error throughout these types of problems today. All right, let's take a look at it's already in the Delta Math walkthrough, but this lesson's a little short, so let's do a Delta Math problem together. And I am going to be, you can turn on your microphones, you don't need to raise your hands, you can shout at me while we do Delta Math. Don't shout, just turn on your mics and talk. So here we go. Nassim spots an airplane on radar that's currently approaching in a straight line. And let's draw our diagram. Oh, that's too big. And we'll get our numbers. And we'll put our numbers on here. Okay. All right, so here we go. And that will fly directly overhead. So it's not flying this way, it's flying this way, overhead. Okay. The plane maintains a constant altitude of 5,975 feet. All right, so here is N for Nassim down here. Here is A for airplane up here. And Nassim initially measures an angle of elevation of 17 degrees to the point A. Oh, I already labeled it A for airplane. All right. At some later time, he measures an angle of 35 degrees to the plane at point B. Okay, so let's draw it. Here we go. It's approaching a straight line, means it's coming straight at him. It's not going that way, like it's tangentially going at. It's going to go straight overhead. That's important, because otherwise we'll need more complex math. So here's the first triangle, N to this point A, and it comes down to N. And then the plane is at 5,975 feet. Okay, and then this is 17 degrees. Okay, and this is a right angle, because heights are always right angles with the ground. All right, and now the plane flies overhead. So I change colors because that helps me draw it a little bit better. Constant altitude, so this comes over here. Let's put it there, boop. And then this is down to Nassim. I like to make sure I'm being clear that this is the angle that I'm measuring as 35 degrees. Okay, that's this information there. To the plane at point B. Okay, the height of the plane is still 5,975. This is still 5,975. 5,975. That's this side of the plane. So that's this side of the triangle. Okay, so now we want to know the distance that the plane traveled from point A to point B. And this is pretty neat, eh? If you knew how high a plane was, and then you saw that it was flying overhead, you could just measure the angle and figure out how far it goes. Then you could figure out the plane's speed just from being on the ground, just by doing some. If you have a time measurement for point A and a time measurement for point B, division gives you speed. So that's pretty cool. It's just angles and you measure speed. I love it. I think it's neat. All right, so let's take a look. Draw two triangles. Here is triangle NA, and this one doesn't matter. All right. Okay. So here is triangle NA ground. And then this is ground here. This is this. This is 5,975. And this is 17 degrees. And then my next triangle, I'm just going to make this big here. Move this over. My next triangle will be NB, whatever, using a different color. Okay. So here's the other triangle. Here's still ground. It's a different point than ground, so maybe we'll call that A, B, C, D, F, G, H. Call that H. Okay, and this is B, and this is still Nassim. Okay, this is still 5,975, but this is now a 35-degree angle. All right, and what I'm looking for is to find this distance. So that distance will be this distance minus that distance. So let's label it. So the desired thing that we're looking for is the distance traveled by the plane, and it's equal to, call this side A and this side B. Okay, it's equal to A minus B. Can people see why? This is A, this is B, this is the distance traveled. So if I take A and I subtract B, then I get the distance traveled. That's why I like having a diagram that's together, and then I blow it up into two diagrams so that I can do my trig correctly. So I need to find A and B. So looks like I need to use which trigonometric ratio, people? In both triangles? It's the same one. Sine, cosine, or tangent? Which one? Cue the Jeopardy music. Oh, people are writing in the chat.
Tan.
Tan, that's right. Yes, it's tan. Tan is correct. So we use tangent because we're relating opposite and adjacent. So we write it down over here. This one is tan 17 degrees is equal to 5975 divided by A. And then some quick algebraic manipulation gives us this is A is equal to 5975 divided by tan 17. That's calculator punchable. Okay, and then let's find B over here. So B is B is equal to 5975 divided by tan 35. Okay, by the same idea, I would have tan 35 equals this over B, and then I do my flippy flip and get that. Okay, if you write that straight away, that shows me that, I'm still going to give you marks. You're showing me your work, you're showing me where your numbers come from, and I can see that you can do that quick algebraic manipulation in your head now because you've had so much practice with trigonometry. All right, so let's punch these two things, and then we'll get A minus B, and then we'll be able to put it in there to D. We would actually do it this way and punch the whole thing on a calculator. Watch this. D is equal to A. I'm going to write that down. I'll write it in blue so that it's write it with this pen in blue. That way I don't need to keep changing the color of the pen. Is equal to 5975 over tan 17. Why did I write 15? That's so weird. 17 minus, using this one, 5975 over tan 35. Okay, that's B. See, I just substitute them into this formula that we created. And now, can you see that that can be factored? It can be factored. Watch, this makes it a little simpler to punch on the calculator. D is equal to, factor out the 5975, multiplied by 1 over tan 17 minus 1 over tan 35. Okay? That's going to be something we can punch on the calculator to get the answer. All right, let's do it. Boop, 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 boop. Make this smaller. Move it over where I can see what I'm punching on the calculator. Get my calculator out. Move it to where it doesn't obscure things. Oh, it's still obscuring things. Thank you for your patience, everyone, during distance learning. I appreciate all of you, and you're showing up for your learning every day, and you're hanging out with me to do math together. I know it's not optimal. I know maybe doing Fortnite is a sweeter use of your time, but I appreciate you showing up for dinner with me every day. 5975 multiplied by bracket. 1 divided by the tangent of 17. Okay. Minus 1 divided by tangent of 35. End bracket equals, okay, so this is what we're getting as an answer. The plane has traveled, these are meters, so 11 kilometers and 10 meters, 0.16. Okay, so I'm going to grab all of this depending on how much detail they're looking for. Copy, move over here, Nassim, blah, 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 round it to the nearest foot. Oh, these are feet, not meters, sorry. So this is not 11 kilometers that the plane has traveled, but it's 11,000 feet. They said round to the nearest foot. So all of those decimal places go away and they don't round up to another foot. So I submit answer. Hooray! You see, all that method worked. Now let's go through. I bet they don't do that trick of factoring out. draw a diagram. Look at how much better their diagrams are than mine. Oh my goodness. So we can learn something from Delta Math for sure. Okay, there we go. It's still 597 there. We want this distance, so we find this triangle and then subtract this distance. That's the same method we used. So there, they do the same thing of drawing out their triangles. All right, so they find x and they do all of that manipulation, and they find that x is equal to this, which we did in one step. So we're skipping steps now, which shows that we're learning. Either that or it shows that I'm confusing you, in which case, please go back to the previous videos or please ask me questions. And then here, this is the other triangle. And they did that. And they found the two distances and they just subtract, Boom, boom. Whereas I do everything in one fell calculator swoop. Pretty cool. And they find that. That's it. So I hope your frigid Friday math practice is fruitful. And I wish you a good day with your practice problems. Does anyone have any questions before we wrap up our video lesson? Now, before you leave, if you haven't met with me to talk about the trigonometry assignment, please meet with me now. I notice that some of you who are leaving are those who have not met with me yet and have not responded to my emails, but I can only do so much at a distance. I think maybe I can do more. I can certainly do more, but it's also adds stress to everyone. All right, Ashley, what's your question?
When is the trigonometry assignment due?
TBD. We talked about having some class time for it when we get back together. So we'll spend some class time on it on the Monday or the Tuesday when we get back together, and it'll probably be due by the end of that week.
Okay, so it's not like due on Sunday or anything, right?
No.
Okay.
Great. Bye for now.